Alright, hello everyone. So this is a guide video for the AWR and Axiem RF simulation software. And in this video, I would be designing a simple RF circuit in order to show the steps involved in designing the circuit and then obtaining its Jabber file in order to have a physical PCB of that circuit. So the simple RF circuit that I would design in this video with this tool would be a filter, and then we would perform some geometrical tuning in order to optimize our design requirements. So in order to start, you first of all have to go to files, then go to new with library and AWR example libraries, and in that we are going to use AWR modules. Right, so once you have that, you have to set the options for the project, in which you are going to specify the start and the end frequency. So for our purpose, I'm going to use the range of 5 gigahertz from 1 to 5 gigahertz with the step of 0.01 gigahertz. You can change it according to your application, depending upon the type of circuit that you are designing, but for this video I would be having the range of 5 gigahertz. Once you have set the start, stop, and step ranges, just click apply. And yeah, once you have set the range, you can move to change the global units. You have to ensure that the files that is selected here is AWR module LPF. In most of the cases, this would be the only file that you will have, so you don't have to worry about that, and just select OK. Right. So once you have that, you can go to the project and then the circuit schematics, and then just add a new schematic here. Name it whatever you want to, and once you have that, the output window would be something like this. So the schematic of the circuit would be designed in this window, and the simulation output results would be obtained in another window that I will show you later on. Right, so once you have that, you can have the circuit element selected from the bottom left corner right here. So these are all the elements of the circuit or of the RF circuit that you can have. And since we are designing a filter, a simple filter, we are going to select some element from the microstrip. So first of all, we want a line for the microstrip, and you can select a microstrip line right here. So I would be using that. So a simple line would look something like this. It's a medium transmission line with the width and length given as default. This can be changed later. We would see how, and also how the tuning is done for these parameters. So once you have that, you can double click it to see its further properties. We would be changing some of these properties later on using the tuning tool. Right, so for this particular transmission line, we can have some, we have this TX line tool, which is used to automatically tune the length and width of the transmission line with the given parameters for the impedance, frequency, electrical lengths, and the type of the material parameter that you want. So for this particular application, I would have gallium arsenide as a dielectric. Conductor would be copper, and conductivity is by default, and the dielectric constant can be selected to be 2.54. So this is according to one of the specification that I have for one of my project. You can change them accordingly to your application. And loss tangent would be 0.06. Similarly, impedance, characteristic impedance is 50 ohms. The cutoff frequency would be 2.5 gigahertz, and electrical length would be 90. So once you have these parameters, just click just right arrow right here, and you will have the automatic parameters for the length and the width of the microstrip, along with the height and thickness as well. Okay, so once you have that, just close this, and actually you should ideally change the the parameters that you have obtained from that tx line right here. So let me just see, the physical length would be 20,566, and similarly the width is 4,307. So just change the parameters that you have find in the automatic tool in here. Right. So once you have that, you can decide what kind of substrate do you want for the transmission line. You can go to the substrate option right here. Just select this and go to the. So for this particular application, I'm going to use the microstrip substrate definition. So let me just obtain this right here. So this has the all the predefined default properties of this microstrip substrate that is given. You can change these parameters as well, but for now I'm going to leave them as they are. And furthermore, you can also obtain this substrate properties from here, from the option of the AWR module, which is given by the default. So I'm going to be using this one. So you can just select this and change its property from its parameter options as per your need. So the some of the properties that I would be using that I have set in my simulation would have to be changed here. So these are the same ones that I use to find the width and the length of the microstrip. So you can just change them accordingly. So once you have that, just copy it and just paste it here, and you can just delete this only. So this module right here is going to just define the properties of the substrate that you have. Right, so once we have the microstrip line, we can then find the T junction within the same categories of the microstrip right here. We have the junctions right here. Okay, so just connect the two. So this is the transmission line, and this is the corresponding T junction for the filter. Similarly, you can copy this from here and just paste it here, as both of these transmission lines would have the similar properties. Um, all right. So once you have that, you need the ports, the closing ports for the reference impedance, and for that you can just select the port from here and close it on both sides. So I would be using the both the closing ports to be of that impedance having 50 ohms. You can change them according to your application, of course, but for this one I'm just going to be using the 50 ohms closing ports. And lastly, we are going to close it uh, on a stub. So let me see where we can get the stub from. Right, so in order to obtain the stub, you can just go to the lines in the microstrip section and just select the microstrip line with the end effect right here.